Okay, students, in this video I'm going to walk you through some examples of how you can use your shortcuts, your relationships that we found in the 45, 45, 90 triangles to avoid having to use trigonometry because it's going to take longer, and most importantly we want to end up with some exact answers for the lengths of x and y, and trig does not allow us to get exact answers. So without further ado, let's talk about 7 and 8 on your worksheet, but I'm actually going to go back real quick to number 6. 6, I'm pretty sure you were able to get. Y should have been 9 because the legs are equal, and x should be 9 radical 2. And that's the easiest one, where I give you a length for the leg, and then you just have to multiply by a radical 2. Can't actually combine the 9 and the radical 2. So you're done. 7 probably was also pretty easy for you. See if you were able to get this one. You should have gotten x and y are both 33. And if you're able to get that, you definitely see the pattern there. And you probably just thought of it as, okay, I take off the radical 2. Now, I'm going to take a minute and mathematically explain what's happening, because we don't really just get rid of the radical 2, what's actually happening. And that, of course, is going to help us with number 8. If you want to try it, you can go ahead and try and see if you can get the answer to number 8. The answer should be 25 radical 2 for both x and y. If you're able to get that, you can skip the rest of this video. But if you're not sure, go ahead and watch. I won't take too long. I'm going to walk you through it. Okay, let's go back to 7. So we learned from our discovery, and in my last really short video, that the hypotenuse in a 45-90 triangle is equal to the leg times radical 2. So I'm going to use that relationship, and I'm just going to plug in here. So the hypotenuse in this case is my 33 radical 2. So I'm going to plug in, let me change color here, 33 radical 2 on the left side, because that's my hypotenuse length. And then my leg length is x or y, doesn't matter what variable you use. We're used to using x, so I'm going to put an x there. And I'm rewriting my equation, but now I've got everything plugged in that I know. The radical 2 is just there. I plugged in the hypotenuse length, and I plugged in the leg length. Okay, and one of those is always going to be your variable. Obviously, in this case, the variable is the leg, and algebra now tells me, because I'm going back to algebra, because I have an algebraic equation, algebra tells me, hey, I want to solve for x. I've got x times radical 2. Don't worry about the fact that it's a radical. X times a number. Solve for x by doing the opposite, which is, of course, dividing. So I'm going to divide by radical 2 on both sides. And what we wanted to happen is we wanted the radicals to cancel. They do. We get x by itself. Beautiful. Is equal to, and on the left-hand side, things work out pretty sweet for us. The radicals cancel again, and I've got x is equal to 33. And that's how I get that nice simple answer of 33. So what's happening with your radical 2, hopefully you can see, is that you're dividing by the radical 2 and it's canceling. You're not just literally getting rid of it. Now let's try number 8. And feel free to try this one on your own and then check your answer. That's fine. I'm going to follow the same process. Hypotenuse this time is 50 right here. And then, of course, I can use the x or the y for the leg. And things are going to look very similar to what I just did in number 7. I'm dividing by the radical 2 again. It cancels on the right-hand side. I've got x by itself. Beautiful. Things are looking great until I look at the left side, and I don't have a radical in the numerator to cancel with the radical in the denominator. So I'm left with this 50 over radical 2. And that would be fine, except for the fact that last year, at some point when you're working with radical expressions, you hopefully learned that it's not acceptable to have a radical in the denominator of a fraction. That's not considered simplest form. So we need to simplify our radical expression. Otherwise, our algebra is done. So the rest of my work is going to be just with the goal of simplifying that expression, 50 over radical 2. We're going to use a process that we call rationalizing the denominator. You may not remember the actual name of it, but I'm guessing that you remember doing it. If you're thinking multiply by radical 2 over radical 2, you are remembering correctly. So I've got 50 radical 2 on the top, because when I multiply fractions, I just multiply across the top, the numerator, and across the denominator. I can't actually multiply the 50 and the 2 since the 50 is outside the radical, the 2 is inside. I get radical 2 times radical 2 gives me radical 4, and that simplifies to just a good old 2. So we are recognizing that this part right here is radical 2 squared. And that, by the way, is why this works, is rationalizing the denominator, because you're always going to end up with a radical expression that you're squaring. The squaring and the radical cancel each other out, and you're left with just the inside of whatever was in the radical. Almost done here. Just have to remember that I have a fraction now, and I have to simplify my fraction. 50 over 2. 50 divided by 2 simplifies to 25 over 1. And that gives me a good old 25 radical 2. I don't need the denominator because it's just 1. And that's what I told you in the very beginning of this problem, or beginning of the video. X and y will both be 25 radical 2. Okay, so there you have it. One of your more complicated 45/45/90s, because it doesn't appear that I gave you nice information. You don't have a radical length for the hypotenuse. So we're not going to be scared of that one anymore. Just use your formula maybe to help you out with that if you are confused on it. Okay, so there's some basic examples. I think you should be good to do the rest of that worksheet.